12:02 Central Time. Today is a great pleasure for me to introduce a colleague of mine, Roberto Kirchheim, from Brazil, from the Serviço Geológico of Brazil, or the Brazilian Geological Survey. I met Roberto a few years ago during meetings with the International Atomic Energy Agency, and it has been always a really, really good to talk to him about groundwater issues, but not only about science. I think Roberto has some skills that are sometimes really hard to find. He's always really open for new ideas. He's a really enthusiastic person. I think some of the energy that he's always carrying is spread with other colleagues. So it is just an amazing experience to talk to him. So Roberto graduated from in geology from the Federal University of Rio Grande do Sul. Then he actually did a couple of years of postgraduate studies in hydrogeology and applied geology from the Karl Eberhard University in Tübingen, Germany. And he also was studying over there water resources and sanitation. He also studied water resources and sanitation from the University of Rio Grande do Sul. And then he did a PhD at the University of Estadual Paulista in Rio Claro, where he obtained his PhD. His career, or his professional career, has been quite amazing. So he began his professional activity in humanitarian projects with refugees during the civil war in Mozambique. He worked as a consultant in water resources and hydrogeology in regional projects, state and basin plans, as well as groundwater management frameworks. He was a consultant for many different United Nations organizations and the Organization of American States as well. For 6 years, he was the operational manager of the international projects as a career employee of the Organization of the American States in Montevideo, Uruguay, and also in Washington, D.C. He joined the Geological Survey of Brazil in 2010, so 15 years ago, where he worked as a hydrogeology researcher and national coordinator of the isotope applications in hydrology projects, advisory of different committees, and head of the International Advisory Office of this geological survey. Currently, he's working as a researcher at the Center of Applied Geosciences and Innovation and Research and Development. He has published several publications, mainly in the topic of groundwater hydrology. He has been a speaker and moderator of national and international seminars and technical events. He just went to Thailand to give a short workshop on isotopic techniques as well. He's fluent in 4 or 3 different languages. And so to me, for me and for this seminar, I think we have an open mic. Let me, please. I think we have a couple of open mics. I will appreciate if you can mute those. Let me see if I can do it. And so for me and for the community, it's a great pleasure to have you. I know this is going to be a great talk, and we are closing our 2nd year of seminars, and we are starting in February with the 3rd year of seminars for the isotope hydrology seminar series for Latin America and the Caribbean. So with that, Roberto, the floor is all yours. Thank you very much for accepting my invitation, and I know that this is going to be a great journey, as we can see from your picture in the Amazon River. So
thanks a lot, Ricardo. The pleasure is all mine, and thanks also for the audience, those colleagues, isotope colleagues from our beloved continents, plus Central America, Caribbean, and America in general. It's a pleasure. I think this idea of the seminar, it's amazing. It's very good. It's a very good idea to speak to our neighbors. And by saying that, I'm a very enthusiastic person of the South-South cooperation, and this is something that we try hard here at the Geological Survey of Brazil, always to connect with our neighbors and with people from the continent that we know that are doing a great job. And I think it makes a lot of sense to work with this perspective. So that's why I put also the title, and I named the word grassroots idea. It has lots of things to do with this South-South cooperation, and also with ideas that comes from the floor of any institution in our continent. So I'm representing the Geological Survey, where I'm a researcher, and I do also work in a team with very young, talented people. Uh, and the whole Isotope program inside the Geological Survey has started from the fabric floor. So it was not an idea that came from the top, from our top managers, but was an idea that started on the technical side, on the technical level, and slowly started to give lots of interesting outcomes and results, like we are going to see. Uh, so, like any geological survey in the world, we do have a mission that is to generate and disseminate geoscientific knowledge and contribute to the quality of life of people here in Brazil. And yes, we do have a national program for isotope applications and hydrology. So this is very important to say, because we are very proud of this national program. So this is the places where we are. We have our headquarters, like you see here in the Brazilian map. We more or less are very present in all sides of the country, which is very big, and that gives us a very large capillarity and a very good point to go to the field and take samples and do whatever has to be done in the field. So this is a very strong point of our teams. So, and the context why we are all here speaking about isotopes, of course, we see that we need to fill some gaps of information, especially in a period where we are looking more day after day evidences of weather changes affecting water disponibility, superficial groundwater disponibility, especially here in Brazil. The last researchers and papers produced by well-renowned hydrologists, they are pointing out that we are going to suffer a descent in our water disponibility, the low levels, the low yields or the minimal yields of the main of our rivers, they are going to decline. On that, we have to build our models, our conceptual and mathematical models based on very strong information, and at the end to give the water in a very equitable share to everybody, and not concentrating the water resources in the hands of few people, like in many places we see, and especially here in Brazil, it might be the case for many regions. So our national program for isotopes started in 2015, so we are very young, and still after these years, we were able to do lots of very interesting things from the technical side and also from the political side. From the political side, I think it's important to mention that we were recognized by the agency to be a collaborative center for the agency. And that puts us in a very nice position to work in partnerships with other institutions. For example, with a very good colleague and friend of mine who you know, Didier Gastmans from the UNESCO University, for example. We work very close in collaboration with his team and other teams. Also, uh, for instance, we were able to work with the group of Daniel Martinez from Argentina, also a very good friend of us. And so with other groups from Uruguay as well. And also, uh, by giving this example of this very important effort for building also the political strength of the program, we were able to put our names in the country program framework for the agency, for all the research done with nuclear applications for peace. In the chapter of water, we are there recognized as a collaborative center for the agency, and this is something that is very important because this is a framework valid for 5 years, where we are formally recognized to be an institution in Brazil able to work with isotopes in water, and that is a kind of open doors for us. So our program is based in uh, 8 components. I will not read component by component, but as you know, some of them are dealing with precipitations in isotopes in precipitation. Another component is deal with isotopes in rivers, and so on. And also at the very end, we look also we do care for technical training and dissemination, and also for expansion of analytical capabilities. So we more or less we work in a very integrative way, and our idea is to provide answers and not like being apathic and don't do anything or do wrong things like in the figures here in the slides where people are just waiting until the drops are falling. So we are active in terms of looking for partnerships, looking for articulation, looking for good ideas, and also to go to the field and take samples and try our best. So this is a picture where we were recognized as a collaborative center. And in this picture in the right, where you see the world map, if you look into Brazil, there is a Geneve station pointing to Porto Alegre in the southern of Brazil. That was the first Geneve station that was built, that has re-inaugurated a network that Brazil used to have during the 70s and the 80s. And so that one was the first one among the 30 ones that we are operating right now. So this is speaking about isotopes. This is our network today. It's comprised of 30 devices for collecting monthly rain samples. And we are right now hurrying up to inaugurate and put all this information in our websites, making this information available for everybody. This is an information that is very, very valuable, that a lot of people are waiting for this information. So, and we are really very proud to be able to offer this to Brazilian society. And we have done this with the collaboration of many institutions, like you can see here in the right side of the map, where you see lots of universities and other research centers across the whole country. So this is more or less how a Geneve station looks like here in Brazil, with a colleague of us collecting samples. The samples are being shipped to Vienna, And we hope not to ship them to Vienna for in the future, because we want to analyze them here in our own laboratories. So this is the Genib station in Porto Alegre, and also the meteoric water line. And so this is the way we work further with Genib. Another very important project of us is wetlands. So we care a lot for wetlands. It's a great opportunity to understand the surface and groundwater interactions. So we can combine stable isotopes with noble gas isotopes, with radon measurements, plus hydrochemistry, plus hydrological modeling, plus some thermal radar zonings and assessments. And we are working in two very interesting wetlands in Brazil, one in São Paulo and one down here in Porto Alegre, where there are many environmental issues and many questions to understand the water dynamic, uh, which is important to keep and maintain the ecosystem. So, of course, there are lots of stresses. Some of wetlands are shrinking because of the weather, because of too much water intake, out extraction around. So we feel that we must be there to answer those questions, and why not isotopes? So this is some pictures from field work. As I told you, we have a very nice and talented group of young people that love to go to the field, and they are trained to take samples. So sometimes we go with boats, cars, and so we are very well equipped to go to field and take samples. Here in the main picture, you see this low land. This is more or less where the wetland is located. It is much bigger than this picture. And down there you see that sometimes the forest just uh, that is in the margin of the wetland, because of the very dry weather, there is fire, and sometimes when we are in the field we have to help to make the fire down. And so this is, many things can happen when you are in the field. So this is moving to engineer to isotopes in rivers. We are doing this in a group of rivers in Brazil, in different regions. So the way we do it, we do a full assessment for in every season. So to get the full picture and dynamic of the river before we build a permanent systematic monitoring plan, not with so many points like in the assessments, but with in a permanent way year after year. So we have done this in very important rivers, and this is a big, interesting project that also can help many young researchers, and also water policy in Brazil. So also within the Janir, we just finished a 2,500-kilometer river sampling campaign across the main rivers in the Amazonic biome, where we were able to take samples every 20 kilometers in 3 different depths in the very superficial water, 5 meters and 10 meters. So we have taken samples for stable isotopes, for radon, for strontium isotopes, and also for hydrochemistry. And we are just analyzing this collection right now. And I think this is the biggest isotope campaign in the world in terms of distance of rivers. And we are very proud to have done it. And I just told Ricardo before that we have done it without a single piece of paper signed. So it was done because of confidence, because of the need of the military boats to help survey and research campaigns in Brazil. And by doing this, we have opened a very interesting door future campaigns. So for 2026, we have already two campaigns scheduled, more or less in the same procedure, plus other tracers are going to be incorporated as well. And we are very happy with that. And we think that these results are going to be huge. And Ricardo is also helping us. Didier Gastman is helping us. So many colleagues are helping us. And we think we are going to be able to produce very nice material. So we also work with marine expeditions. So we are collecting samples in different depths in different parts of our ocean. For noble gas, for example, argon 39 for understanding the movement of the marine masses, and also stable isotopes. And this is also very interesting. Brazil has a research vessel, and we are in our campaigns. At least one person of our teams is always there to help doing those sampling campaigns. So this is more or less where we are working right now in our projects in Brazil. So again, stable isotopes engineer, so in precipitations, in rivers, in groundwater, in different places, and also we are very good, at least here in Brazil, I can say that with noble gas sampling campaigns, and also measurements and interpretations of data, especially helium-4 and krypton-81. I just came back from China, where I went in a fellow for 2 weeks to understand and get a better picture of the atom trap trace analysis, producing krypton-81 ages and also argon-39. And that was a very interesting experience. So I hope that also this connection to China is going to help us also in the next projects. Just like our colleague Daniel has done lots of things with them, and I think it's a very good idea to work with those tracers that are analyzed in Hefei in China mostly. So right now I'm going to speak about noble gases and a bit more in detail what we have done in the Guarani Aquifer system. Probably many of you did hear about this transboundary aquifer, which is lying in the southern part of the South American continent, where Argentina, Paraguay, and Uruguay, they have also a chunk of this transboundary aquifer. It's mainly a confined aquifer, which is outcropping in the borders in a very narrow fringe. So the recharge, it's not that much like we supposed that it was. And here you see some outcrop features of this very beautiful sandstone, like a Saharan sandstone. And you see that in the deeper parts of the basin, you have a basalt cover of more than 1 kilometer, and the Guarani is pretty much confined. So during the early years of the 2003 to 2009, some sampling campaigns conducted by the agency under the framework of a Global Environmental Facility World Bank project has been taking place in the Guarani Aquifer, and so many new samples were taken for carbon 14, giving ages in the very close to the limits of the functionality of this tracer. So then many scientists, they were aware that probably those waters in this very deep areas, they must be much older than 40,000 years to the limit of the carbon 14 tracer. So just after that, we were able then to start a complementation.
Sí, pero yo no puedo ir. No, yo no voy.
Sorry, Roberto. I think that there is a mic open, please.
All right.
You can.
Thanks, Ricardo. I think that has been fixed. So later on, we were able to enlarge the sampling campaigns for the Guarani. Right now, looking for noble gas tracers. So here in all those points, you see how far we went taking samples. I did this campaign myself, just traveling all over in the Brazilian part of the Guarani aquifer, taking samples for noble gas and also for hydrochemistry. So then, thanks to the agency, we are able to receive some capacity building for dealing with noble gases and understanding how those traces work and what we need to do and to understand to cope with measurements and to try to get hydrogeological information, like working with solubilities in different temperatures, different altitudes, different salinity contents, also to understand what are the geological constraints for having a richer helium-3 or a richer helium-4, what's the difference among them, dealing also with the noble gas excess, which is a component that it has to be put into the solution for retrieving at the end the pterogenic helium-4, like we are going to see afterwards. So once you get the results from the laboratory, we need to understand how those models work. This is a novel, the version 2.7 of the iNoble, produced by the agency. There are other models to cope with noble gas measurements, just like the Pepenga from the University of Heidelberg. So, but more or less, you go one by one, sample by sample, and then at the end, the model just calculates the helium, the pterogenic helium-4, which is a proxy for residence time and gives us very interesting information. And also at the end, you get the excess air content and also the paleo recharge, the noble gas paleo recharge temperature, which is at the end very useful for paleoclimatic assessments. So it's important to understand the full stratigraphy of the water well and also where the filters are positioned, because this information is very important for the modeling part. So and also you have to have at least an idea of the conceptual model, because you need the distance from the recharge area. You have to understand where more or less the recharge area is lying, so to more or less come with a nice interpretation. So the wells in Brazil can be very heterogeneous in terms of the outlet of the water. So that means you have to carry a bag with lots of hydraulic devices to get this outsplit of water into a laminar flow, so that you can get the water or catch the water using copper tubes, and also sometimes when we do a gas extraction for Krypton 81 sampling and measurements, you need to have a gas extractor. So here in the left down picture, you see the gas extractor under operation. Right now, that one is broken. Didier Gastman is building a new one. And meanwhile, we got very nice support from our Argentinian friends, and they borrowed us their machine so that we were able to extract gas and to sample the Guarani for Krypton 81 again. So the isotope assessments, they were very useful to change the way people understood the dynamic of the whole aquifer. So here you see different phases, different conceptual models. They have evolved and the isotopes, they played a major role in giving light and allowing the development of new models. And right now we are in this right side model, where the Guarani is more or less divided in 4 domains, and where some very large tectonic structures, they kind of affect the regional flow somehow. And by understanding and by studying the isotopes, we are able also to understand how far this effect, this structural effect, may change the water dynamic, and so many other questions can be solved. So again, this is an aquifer which is pretty much controlled by the storage component, because of those huge confinements, and also it's a very thick aquifer that can be very heterogeneous, like you see here from from these pictures from the microscope. Sometimes people think that because it's a sandstone, it's very homogeneous, but this is not the case. It's very heterogeneous, and that promotes, of course, different paths in the porous media, affecting the main mechanisms of transport, of advection, and dispersion, and so on. So, in a very famous paper published in Nature by Agaval et al. In 2014 or 2015, I think it's 2014, that's right. Some krypton ages were interpreted, and some noble gases also. And on that paper, they tried to start to work with the chronometer helium-4 krypton 81, and also looking into those helium fluxes from the crust, how they were stored in the aquifer, and how far they give information on residence times of the Guarani aquifer. So this was a very nice paper that I were able to repeat all those procedures. Well, I will not go into detail what on the information that is produced by this paper, but I will talk later on about some of them. Here you see the different campaigns, and our main research questions were about the helium production rates, if they were the same in the whole aquifer or different, and why. What are the mechanisms that affect those helium influxes, and what's going on in the different geotectonical settings of the sedimentary basin. So, and then of course, once we send the samples to the laboratory, then we get the results from the laboratory, and then we look to all those numbers, and with then we start thinking, so what shall we do with all those numbers for helium, neon, argon, krypton, xenon, and also the ratio helium-3, helium-4. So, and then, of course, you have to go into the model that I showed you before, but remember that I told you that it's very important to understand where the recharge area are, and also to have an idea on the conceptual model. That means you have to understand where the flow lines are. And so what we have done is we divided the Brazilian part of the aquifer in 5 different polygons that were called recharge polygons. As you can see here, polygon 1, 2, 3, 4, and 5. And then you see that every flow line sometimes connects 1, 2, 3, or 4 wells. And from all those wells, we do know then the hydrochemistry, the stable isotopes content, the double gas contents that were modeled to get the age and also the paleo recharge temperatures. So then you can start playing around with this data, trying to understand the geochemistry evolution along the flow line, and if the ages are coherent with this hydrochemical evolution. And well, there are many things that can explore with this data, but considering the recharge area, it's important to get the actual scenario of those recharge areas in terms of the location, the actual temperatures, mean, maximum, and mean values, the actual precipitation rates, the amplitude of the fluctuations of the groundwater levels, of the Guarani water levels, the maximal amplitude, and also what's going on, what's the fingerprint of stable isotopes of the very young recharged water. So, and later on, you are going to understand why we have to do this, because we are going to compare what's going on today with what has been looking into the past. How was the paleoclimatic history of every single recharge polygon with the information that we got from our modeling? So here a closer look into the recharge polygon number 1, and then you see here in the right side the hydrochemistry evolution, starting with bicarbonate calcic waters, evolving until sodic waters with some anomalous content of sulfate and also chloride. And because of this evolution, and also because of some mixture with waters from below, from Permian, from the aquifers that are underneath the Guarani. So again, the same procedure, one by one, looking for the noble gas temperatures and also the helium-4 content. By modeling, of course, there are some statistics that one has to look for. For example, in this blue dashed water wells, you can clearly see that the statistic was not very good, telling that well cannot be used for further interpretation because the data didn't fit into the model, so you have to repeat the sampling or do something else. So at the end, also, you have to try to separate the components of the helium, remembering that the helium, for the noble gas, especially for helium, we have a radiogenic component, a component that is because of the excess air component, and also a component that it's in equilibrium with the atmosphere. So the one that is of our interest is the radiogenic component, and you see here the difference from those 3 wells. The well down here, the PL62, it's pretty much confined. You see, it's a 1,000-meter well where the electric conductivity is about 400. The temperature is almost 40 degrees, and it has a huge radiogenic component. So there is a buildup of this radiogenic component because of this crust, of this flow from the crust, putting this helium-4 inside the aquifer, which is a proxy to the residence time, like it's written here. So the accumulation rate, it's a proxy for residence time, and that's why it's an interesting chronometer. So, and then of course you can try to investigate the helium-4 concentration combined with the distance to recharge, and try to understand what's going on. And of course, the farther you are from the recharge areas, the more confined the aquifer is, then the more the higher the helium-4 content is. And this is very interesting also to understand the conceptual model. And it's very interesting because here you see some green spots, and those are very, very shallow water wells taking water from the basalts that are on top of the Guarani, and they have in some places they have a similar response for noble gases, telling that there are water mixtures in the basalt, where the water in the basalt, in fact, has a very large influence of the Guarani waters, and the opposite can also be the case in different cases. So the same here, by looking into the ratio, where then you see, for example, some points are clearly wrong in terms of the flow lines. So it cannot be that a well which is so distant from the recharge area has such a low value for this ratio. So this is clearly a misinterpretation of the conceptual model, and that point here, it's probably very close to a recharge area. So this is a very powerful tool to modify the conceptual model, and that has been the case for the southern block of the aquifers. We can do the same, the combination between the helium and the depth of the wells, and then you clearly see different groups. We can do this with this groundwater temperatures, and also you see the different groups. And also you can do the combination between helium and electric conductivity, and also fluor content, and so on. And of course, once you have this dispersed helium information, you can try to understand, well, what are the variables of the basin that are controlling those fluxes? Is it the full sedimentary filling? Is it the depth to the aquifer bottom? Is it the geological framework below the aquifer bottom? Is the aquifer thickness? So lots of statistical assessments can be done by combining those different variables, trying to explain the helium values. And of course, looking into more detail into the way that the helium is being produced, we can also start to calculate the in situ production from the aquifer, or the crustal basic fluxes that are playing a role in this basin. And what we have done, we have worked with this chronometer helium-4 and krypton-81. It's very expensive to analyze krypton-81, so the whole idea was to do lots of helium-4, and by doing this modeling, transform the helium-4 concentration into an age by using this helium-4 krypton-81 chronometer. So that has been done in the paper of Nature 2014, and we have done it for the rest of the Guarani in Brazil, with the support of the many helium-4 samples that we have done, like I showed you. And for that part, it's even more important to understand where the filters are, because there are some variables affecting pretty much the modeling. So you have to really understand where the filters are. So it means that the wells, they should be representative wells, and not any well without information. So also we divided the noble gas information into blocks, and for every block, we try to use krypton-81 ages that have been produced nearby. But of course, there are some blocks without any krypton-81 information, but despite this fact, we worked with this statistical coupling model between helium-4 and krypton-81, producing then by this modeling, producing the basal fluxes and the vertical diffusion, which are the most, the two variables that we retrieve for the model. And then at the end, we get the ages for every single well. And then we can understand, we can try to see if there is an agreement between the model ages and the Krypton 81 ages for the same wells. And then for the block 1 and 2, we just got 21% of mean agreement. And for block 3, 11% of mean agreement, which is very good results. And here in this model, you see the different ages produced by different tracers and by different modeling approaches. And then you see that, for example, the red dots and the blue squares are the ages, the absolute ages by Krypton 81. And then the blue ones are the model ages. They are more or less very similar. There is a very nice coincidence where other tracers, they are good for certain distance to the recharge, but at the end they overestimate the ages or they underestimate the ages. So this is a very nice figure. So remember that I told you that we got for every single recharge polygon, we got the actual values for fingerprints, for the stable isotopes fingerprints of the waters today. And that we were able, since we do now have the residence time of every single well, we can do a graph like this, where we combine the residence time for every single wells, combined with the oxygen 18, and the dots, they are colored in according to different recharge polygons. And if you take the recharge polygon number 1, which is the blue one, you can see that during the almost all wells, they are more depleted than the water is today, especially if you see the transition between Pleistocene and Holocene, where the maximal glaciation was taking place here in the southern hemisphere. We can see how more depleted the water was in this period, or along the entry time. But of course, this is a very low frequency sampling, but still we can tell lots of things about what was going on in the paleoclimatology for every single recharge polygons. The same can be done with the temperatures, because we get the paleo recharge temperatures from the noble gas modeling, and then we can again compare those paleo temperatures for every single well with the temperatures of that recharge polygon today. And then we can see, for example, how much less the mean temperature were during this transition between Pleistocene and Holocene. So this is very interesting, and this is a very nice model, a very nice novel to be published, to tell the paleoclimatical history of the recharge areas of the Guarani Aquifer, for example. And this is just about to be published, and we are very proud to have got so far. When you take the NEOM percentage for every single well, you can tell lots of things about the fluctuation amplitudes that were taking place along the history of every single paleo temperature. So very powerful tools, and I think this is a very clever way to work with noble gases. And what we are trying to do right now is to study a bit further where there are some missing gaps. So now we are taking samples from the places where we don't know so much about noble gases. And by doing this, we got some new sets for copper tubes. We got to use the extractor from our friends from Argentina. And now this is some pictures from gas extraction sampling campaigns for very deep wells in the confined area of the Guarani. So right in the near future, we are going to have new Krypton 81 ages from that part of the Guarani. And then the idea is to rebuild the model helium-4 Krypton 81 and get better ages, and then go into an enhanced conceptual model, and then go into a mathematical model, and then at the end, and this is the very most important part, is to help water policy in Brazil to deal with those confined areas and produce a kind of management zoning and so on. So the way we have done here with the Guarani, we are trying to replicate, and we are going to replicate in other very important regional aquifers in Brazil. And by doing this, I'm just finishing my presentation, and I open doors for questions. And thanks a lot.
Thank you, Roberto, for such a comprehensive presentation. Now we open the floor for some questions. Let's see, we got a participation over 30 people. So let's see if we have any questions from the audience.
I hope you understood my English. Sometimes I'm missing some words, or I do bad declination.
No worries. It was totally fine. And I think we can talk in Spanish now. I think should be fine. So Roberto, I have one question. Maybe this is more like, it's not really a scientific question, but
go ahead.
Everybody in every country who has been trying to set up monitoring networks and had been trying to compile spatial distributed data has been always dealing with many different barriers. And we tend to think that in Latin America and the Caribbean, we face the same barriers, either administration barriers, sometimes legal barriers to do sampling, etc. There are many obstacles that are not allowing us to complete our goals. And so I'm wondering if you can tell us something about how you navigate around Brazilian administration to actually be able to conduct all of these sampling campaigns. I mean, you mentioned something about Amazonian without not a single paper being signed, and I mentioned to you that those are probably the best campaigns. But can you tell us something about how you have been dealing from the scientific perspective to deal with lawyers, to deal with politicians, to actually get so much done in Brazil?
Thanks, Ricardo. This is a very provocative question, and I mean, I can tell lots of small stories behind the scenes, but I think partnership with very good research groups in Brazil. For example, Didier Gassmans from the UNESP, he gave me lots of support. In fact, he gave me the first GENIP device that I was able to go back to Porto Alegre, where I come from. So I had friends there in our headquarters of the Geological Survey, and I just decided to build it there. And I took lots of pictures. And then with my colleagues from Porto Alegre, which is long, far away from Rio de Janeiro and Brasilia, where the main headquarters of the Geological Survey are located, they were able, with my supervision, to take monthly samples. And then with those pictures, I sent to the agency, yes, saying, look, we are trying to re-inaugurate the GENIP station, the GENIP monitoring in Brazil. And for my surprise, when I went to the Isotope seminars in Vienna, because I was already enrolled in my PhD, in the main portal of this very nice room in the agency in Vienna, that was this world map showing exactly that GENIP station. And then I brought the managers from Vienna, from the agency, from the Isotope section, And then I took a pictures with them pointing out to that genip. And then with those pictures, I went back to Brazil and showed them. And then I told my managers, look, it may be the case that you think that this is not important, but the world think this is important. So then we were able to start one by one, but always with partnership. And I think partnership in science means partnership. Sometimes you lose and sometimes you gain. And I'm being very honest. I love to work with guys like Didier Gastelmans and many others, because we really share things, and we support ourselves. Otherwise, we would not be able to move further. And sometimes, for example, if I internally say that something is important, perhaps my managers, they will not listen to me. But then I call Ricardo, and then Ricardo say the same thing, or other guys from outside, and then people, oh, there is one guy in Costa Rica saying that this is important. So that's good. So another example is the collection of slides that you produced one time in Costa Rica, showing one by one rain in this graph, and then what happened with the waters from the Paramos, with the water from the groundwater, with the waters from the thermal samples and confined samples, and so on. And I keep using these examples from Costa Rica to do capacity building in Brazil, and people love it. So that's why I think that soft collaboration is so important. And this is something that I learned also when I went to Thailand to give a course on stable isotopes and general issues. People were very happy by realizing that a Brazilian was there, a Brazilian with the same difficulties, the same problems, the same political issues like Pakistan, like Afghanistan, like Vietnam, like Laos. So we have, I think that we have to look more closely to what our neighbors are looking. And if I have to install a new genip in Brazil, I will put it right in the border, so that that information will serve to Brazil and will serve to Bolivia, will serve to Brazil and will serve to Argentina. So this is also a very clever way to move further. But of course, there are many other very interesting stories to tell, but there is no time.
No, yeah, we have another question from Roberto Cerrón from El Salvador. So please go ahead, Roberto.
Thank you, Tocayo Roberto.
Good to see you.
Good to see you too. Well, my question is in line with what Ricardo mentioned, but also what you were mentioning, because we need to collaborate with not only inside the country, but beside that, with other countries. Let's think about analyze the samples. For example, we don't have enough capacity of laboratories to analyze the samples. So we collaborate with regional countries, sending the samples to their laboratories just for analyze these samples, and then we receive the information. But I think we need to continue with the effort of the IAEA, the International Atomic Agency, in enhance the regional laboratories just to collaborate with the country that doesn't have the capacity or enough capacity just for this. So I think we need to enhance this effort from the International Atomic Agency in improve the laboratories capacities in the region. Thank you.
Yes, just a comment, Roberto. Caio, placer. Yes, I fully agree. And what I think, connecting your question with the question from Ricardo before, something that I think it's a very good idea. Those of you, when you go to Vienna to participate in a meeting, please go to see your diplomats from your country. Tell them that you are a researcher from your country, that you are doing this and this and this and that project. Put this in writing, handle this information to them. Try to get the name of your institutions into the country framework so that you are entitled to work with water and isotopes. This is also very important. And I think me and my colleagues, we always do this. Everyone that goes to Vienna gets the telephone, the WhatsApp, whatever, mail, and try to see the permanent mission of Brazil in Vienna and tell them, look, I'm here to do this, my institution does that, and this is important. This is a small seed that goes, it can help a lot, building political strength.
Yeah, no, thank you, Roberto from Salvador, for that comment. And just to wrap up, and thank you, Roberto, for your presentation, all the comments. I think the reason why we are here today, and the reason why we set up this seminar that is happening every 2 months, and it really started now like over a year ago, is that there is an idea that the Latin American and Caribbean community are doing so much in terms of isotope hydrology and using tracers, and we need to collaborate even more. So the idea is to collaborate. There are many groups that are quite advanced. There are many groups that are in the middle of the way. There are groups that are just emerging. And so the idea is that we can collaborate and we can take advantage of those who are more advanced and perhaps get some collaboration with samples and analysis and data analysis, but also we can cross-pollinate. We need to expand the use of these techniques in the region. And we have a paper. Many of you are collaborating in that paper. We have a perspective paper of the use of tracer hydrology in Latin America and the Caribbean, which I think we're going to get the revisions back pretty soon. And the agency is aware of this. The agency is aware of this seminar. The agency is aware of that paper. In fact, Jody Miller participated as a co-author, and she said, this is a great piece, and I'm happy to collaborate. Otherwise, she will say, I'm not really part of this paper, but she is. And so the agency knows what we are doing, and they think that actually our efforts are actually an example for other regions. And so we need to keep working together as a community. I think that's the best we can do to increase the use of these techniques. So with that, thank you, Roberto, again for your time and for a great seminar. I will upload the video in a couple days or maybe tomorrow. We will have another seminar actually from Brazil. It's going to be Didier Gassmans as well from Brazil, and it's going to be in February. So with that, have a really good Christmas break, and I will see you next year. Thank you very much, and have a good afternoon.
You too. Thanks a lot. Bye-bye.
Bye-bye.
Thanks a lot. Thank you.